Hi guys, right now we are on page 163, 4.5, disjunctions. Okay, so yesterday we had conjunctions, today we've got disjunctions, and much like under the conjunctions, I had a bullet pointed list. Here we've got the same thing. For disjunctions, our connecting word is or. We can also represent a disjunction with a V. A disjunction represents the union of everything that's on a number line. And then the inequality symbol for a disjunction is greater than. So either greater than or equal to. And that's how we know we've got a disjunction. So, for example 1, it tells us to graph the inequalities. X is less than -4, or there's our connecting word, X is greater than -1. That word or is how I know for sure that I've got a disjunction as opposed to a conjunction. So when I plot on my number line, I need to make sure that I am recognizing all of the solutions that are on the number line. So X is less than 4, open hole goes to the left. X is greater than -1, open hole goes to the right. Now, if this was a conjunction, we would be looking for where the overlapping of the two lines are. But when you deal with a disjunction, you're talking about everything that's on the number line. In other words, everything that the lines are covering, all the numbers that the lines on your number line are covering, okay? Which is X is less than -4 or X is greater than -1. So that would be the solution for a disjunction. If this was a conjunction and our joining word was and, we would be looking for, again, the overlap here. And because there isn't an overlap, if this was a conjunction, it would be a no solution. But because it's a disjunction and our connecting word is or, we're looking for all of the solutions that are represented on that number line. Okay, there are several different ways that a disjunction can be represented on a number line, and I know that we will definitely get to all of them. Okay, example 2 says solve and graph the solution set of X is less than 4, and here is our V. That again tells us it's a disjunction, and X is less than or equal to 2. All right, so 4 and 2 are the numbers on our number line. Okay, so X is less than 4, open hole goes to the left, or X is less than or equal to +2. So that hole gets filled in and it also goes to the left. Now, because this is a disjunction, we're looking for how much, the union of how much of the number line both of those lines, both of those solutions here cover. Okay? Well, because X is less than 4 covers more of the number line, that would be the solution to our disjunction. Okay? Because we're looking for the union of what's being covered. Well, X is less than 4 covers this part of the graph that X is less than or equal to 2 does not cover. So in essence, if you want to think about it, you could say that when you've got both of the solutions pointing the same way, as we do here, in a disjunction, the answer is which part is covering more of the number line. And we see that that is x is less than 4. So that is another representation of a disjunction when it's graphed. Okay? So far, we've had, this is a classic disjunction where both of the solutions go in opposite directions, and you name both of them as part of the solution. And then we just had where both of the solutions go in the same direction, and the answer to that is the one that covers more of the graph. Okay, so those are so far the two ways that we could represent disjunctions. Okay, so example 3, we have now actual inequalities that we need to solve. 3x plus 4 is greater than 16, or, there's your word or, telling you that it is a disjunction. Negative 5x is less than or equal to 20. Okay, so we're going to solve these one at a time. We're going to put it on a number line, both of our solution sets, and see what the disjunction is. Okay, so we'll subtract 4 from both sides and get that 3x is greater than 12. Divide both sides by 3, and x is greater than 4. Okay, now for the other inequality, because we're dividing by a negative number, remember the rule is that when you divide by a negative number, you change the direction of the sign. Okay, so that less than or equal to is now a greater than or equal to. So our two numbers are negative 4 and positive 4. Okay, x is greater than 4, open circle going to the right, greater than or equal to negative 4, closed circle, and also to the right. So remember, because this is a disjunction, the answer that we're going to be seeking is the one that covers more of the number line, which is x is greater than or equal to negative 4. So this is exactly like the problem that we just did in example 2, except for we had some inequality operations to perform, like subtracting the 4 and then dividing by the 3, and then on the other one dividing by the negative 5 and switching the sign. Okay, now example 4 represents the third and final way that a disjunction can be represented on a graph. Okay, it says solve and graph the solution set of 3x minus 6, 3x minus 6 is less than or equal to 12, and then here is the V that tells us that's a disjunction. So or 5x is greater than negative 25. So on the left side, we're going to add 6 to both sides, and we get that 3x is less than 18. Therefore, x is less than 6. We'll go on the other side, divide both sides by 5. And because the 5 that we're dividing by is positive, we are not changing the sign. Okay, so we get that x is greater than negative 5. Okay, so negative 5 is to the left of positive 6 on a number line. X is less than 6, open, whole, and to the left. And x is greater than 5, negative 5, open, whole. Oh, sorry. This is supposed to be less than or equal to. Okay, sorry about that. And then x is greater than negative 5, open, whole, and to the right. Now, because this is a disjunction, we are looking for what part of the number line is being covered by the solution sets. Take everything that's being covered by both of those arrows, and that's your answer. Okay? Well, it looks like if I keep going this way, I'd go forever to positive infinity. And if I kept going this way, I'd go forever into negative infinity. So what is actually being covered is all real numbers, okay? And that fancy little weird R represents all real numbers. So you could also write all real numbers. That would be another way to express this, all real numbers. Just write it out, okay? So, as a recap, disjunction, before we go any further, we are going to compare disjunction from today with conjunction from yesterday. Okay? So, a disjunction, if on a number line we have, I'm just going to say these are letters A and B. That disjunction would be X is less than A or X is greater than B. If that was the case, and we had that same graph on a conjunction, we would have no solution, because a conjunction is what is being shared, okay, which is nothing. Another way that we can represent a disjunction is A and B, and they are both going in the same direction. The disjunction answer is which one is covering more of the number line. So that would be X is greater than A, because the line that comes from A covers more of the number line than the one that comes from B. If that situation was a conjunction and they were both going the same direction, the conjunction requires that the answer give us when both lines are covering or overlapping the same part of the number line, which would be X is greater than B, because both of the solutions are overlapping, picking up at B and going on to the right. The last disjunction, A and B, we would have A going to the right, say, and B going to the left. If this was a graph in a disjunction, the solution would be all real numbers. If that was the graph in a conjunction, where A goes one way and B goes the other way, we are looking for where the solutions overlap each other. So X is greater than A and less than B. So those are the comparisons. The graphs look exactly the same for each, okay? But the way you answer them is completely different depending upon if you've got a disjunction or a conjunction. Okay, it would probably be a good idea to stop the video, pause it, or while I was talking, make sure you write those down, because those are very important to remember. Okay? All right. Now you've got your conjunction and disjunction and the differences between the graphs, and I will be posting your homework in just a minute. Okay, on page 165, what your homework is going to be is 14 through 28 evens. Now you are going to need to pay very close attention to 22, 24, 26, 28 is in that some of them are conjunctions. They're not all disjunctions. So it's up to you to be able to discern the difference between them. Okay, see you guys.